Hi guys, in this video I want to take you through how we would get the components of a three-dimensional vector. So what I'll do is I'll start out by drawing a 3D XY coordinate or XYZ coordinate axes, and we'll do it quite roughly, right? So what I'll do is I'll draw my first axis, I'll draw my second axis, and then I'll go through here like this, and I'll draw my third, okay? And if I want to remind you, this is the X, this is the Y, and this is the Z axis. And in this particular diagram, I'm going to draw out 2 points. And the focus is on the algebra, so the points don't need to be plotted super accurately, but I'll start out with point A, and I will say that point A coordinates will be -3, -5, and 8. Okay, that's point A. So let's think about where that would be. So -3 means we go backwards in the X direction by 3 units, so maybe somewhere around there. Then we go 5 units in the left of the Y direction from that point. So we'll just say something like 1, 2, 3, 4, and 4 and 5, somewhere around there. Once again, the accuracy is not super important. The algebra is what's going to matter here. And then 8 units up in the Z-axis direction. So we'll just kind of go like, use this, and we'll go like 1, 2, 3, 4, 5, 6, 7, 8. And we'll call that our point A. All right, that's going to be point A. And it consists of the coordinates -3, -5, 8. All right, and that will be the tail of our vector. And point A will connect to point B, which will consist of the coordinates 2, 4, and -3. So let's just approximate where that would be. So I'll take our highlighter out again. We're going 2 in the positive X direction, so something like 1, 2. Then we'll go 4 in the positive Y direction. So I'll just, from here, I'll go like 1, 2, 3, 4, parallel to the X, to the Y axis, I should say. And then 3 units down in terms of Z. So let's just, from here, what we'll do is we'll go 1, 2, 3. Okay, and we'll call that point B right there. Okay, that's going to be point B. Point B, as we said, is 2, 4, -3, and that will be the terminal point in our vector, or if you prefer, the head of the vector. And so what I'll do is I'll take out my ruler and I will proceed to connect the tail of the vector, which is at point A, to the head of the vector, which is at point B. And I will then proceed to draw an arrow. Bit of a clumsy arrow, but nevertheless it's an arrow. And that gives us a picture of this vector in a 3-dimensional frame of reference. And I'll highlight it just so it's totally crystal clear what I'm talking about, like that, like that. Okay, there's our vector. And our job is to figure out the components of this vector that connects point A to point B. That's not a tough task because the components of the vector are simply the differences in terms of its displacement for each axis. So vector AB, which I will write with a AB and a little arrow on top, shall be equal to the points at the terminus, or the terminal end of the vector, minus the points at the tail of the vector. Or if you prefer, the points at the head of the vector minus the points of the tail. So vector A shall consist of 2, right, which is our head point for the X value, minus -3, which is the tail point for the x-axis. Furthermore, the y displacement that occurs in this vector is the head value for y, which is 4, minus the tail value for y, which is -5. And finally, the z component and displacement can be calculated as going to be the head component of z, which happens to be -3, minus the tail component of z, which is just +8. Okay, and these differences in displacement between the head and the tail shall make up the components of the vector. So what we find is that 2 minus -3 is actually 5. 4 minus -3, or that's a 5, my fault. 4 minus -5, that was bad writing there, is equal to 9 because it's a double negative. And -3 minus +8 is -11. So what this means is simply this, that the vector AB, in order for it to traverse the region that it is highlighted by, okay, from point A to point B, must displace itself 5 units in the positive x direction, 9 units in the positive y direction, and 11 units in the -11 units in the z direction. And if you wanted to draw an equivalent vector to that as a position vector, you would simply place the tail at the origin, 0, 0, 0, and then you would move 5 units in the x direction, 9 units in the y direction, and -11 units in the z direction. So it starts quite high and it ends lower. And the only other way that we could potentially write this vector, if it comes to mind, is we could write vector A as a amalgamation of the standard basis unit vectors. We could say that vector AB is equal to 5i plus 9j minus 11, and then the k is what we're looking at for. Okay, the k is what we're looking at when it comes to the z direction in terms of standard basis units. Okay, so that's how we write a vector when we have a three-dimensional coordinate plane if we're given 2 points on that vector. And I want you to take note of the fact once again that I did not get too bogged down with the accuracy of my drawing. I did try to make it roughly accurate, but I certainly didn't begin to draw, overly precise prisms and ways of getting that vector perfect. My concern was just to give you a rough representation of the vector in 3 space, or 3 dimensions if you prefer, and then to do the required algebra that would be necessary in order to attain the vector components. Okay, and we did that. So you can do that for any 2 points on a 3D axes system, and you'll find that you'll be able to do that quite easily. Just be careful of your double negatives, and you should be fine. Have a great day. Thank you.